Hi everyone, welcome to my YouTube channel. So in today's video, we actually would be introducing OpenCV. So this is a new channel, this is a new playlist, and this is the first video of our playlist. So if you do like the video, please make sure that you leave a like, you subscribe to my channel, and you leave your comments right down below the comment section. So in today's video, I would be introducing about OpenCV. We would understand what it does, how it is important in Python, how it is helpful in machine learning and deep learning applications. So I would tell you a lot of theory, but that would just bore you. So I think what we would do is we would start learning about OpenCV with a small project. So let's directly hop on to the project. Before hopping on, if there are any queries regarding this video, then make sure that after end of the video you mark those queries in the comment section. Okay, so before we start with the project, I'll introduce the project. The project is a simple object detection system. So with the help of OpenCV and with the help of an inbuilt machine learning model, we would be building an object detection system that would be able to detect object from an image. We'll give image as an input, and as the output we will receive the detected object which would be marked in that image. So this is everything that we are doing. Okay, now let's start creating the project. Now let us start creating our object detection model, understanding each and every line of the code. So as you can see, this is our folder structure. It is already having a few files. These files are required for the project's configuration. So the data file .pbtxt that we have over here helps us with the configuration of our model with the entire code, and the frozen interference graph.pb helps us in understanding the complete architecture of the model that we are using. It is an object detection model that is capable of detecting objects. We have not created it, we have obtained it from the web. You'll find all of this attached in the GitHub repository mentioned in the description. Then we have this Python file. This is where all of our code would be written. Object.names is a file that contains name of all the objects that the model is capable of detecting. So you would be finding a few names. There are 91 objects. So these are the objects that the model can detect. And requirements.txt is a file that would contain all the libraries needed for our project. So OpenCV, Python, NumPy and below are the three libraries we would be needing for our project. So we would just install all the required libraries using this command, that install dash r requirements .txt. So this will make sure that all the required libraries are installed, and once this is done, we'll start typing the code. So we'll import all the libraries first. CV2, OpenCV's library, useful for image capturing and useful for integrating the model. Then we have NumPy, a library from data analysis, very helpful in this case because we would be treating image as an array of multiple values, and that array would be handled using NumPy. Then we have pillow that would help us with handling different tasks regarding the image. So after this is done, the next thing that we would do is we would set a configuration threshold. So this is needed to make sure that when an object is able to exceed this specific threshold, only then we mark it as detected. So my model cannot detect any object with 100% accuracy. So we need to make sure that at least some accuracy is maintained. So that is what we are specifying here, that the model should be able to detect an object with at least 50% accuracy. If it detects it with a minimum of 50% accuracy, then we'll mark that object as detected, otherwise it will go undetected. Then we'll mention configuration file, that's nothing but this data file.pbtxt. So / data file.pbtxt. Then I need to import the entire architecture of our model. So that would be done with the help of this file over here. So frozen model equals dot slash frozen inference graph.pb. Now we also need to know that what are the objects that we can actually detect. So for the same thing we have this objects.names. So I'll just mention class file equals objects.names. Now there would be an image that we would work on, so that image needs to be mentioned. So I'll mention the image file, this is the image file. Okay, so now we need to make sure that this model is loaded. It's a deep learning model, so we'll just load it using CV2, OpenCV. So I'll mention net equals cv2 dot dnn dot read net from cafe. This will help us, read net from TensorFlow. This will help us in loading the model. So model would be loaded with the help of this file that mentions the architecture and this file that takes care of the configuration. So read net from TensorFlow, frozen model, and configuration file. Configuration file. So read net from TensorFlow, frozen model, configuration file. Now we need to make sure that we are able to open all the object names that we have in the objects.names file. So we'll use file handling with open. The variable used for this objects.names is class file with open class file. I'll have to mention RT. The alias name could be FPT. So we would be reading all the different class names with the help of this variable FPT. We just need to read the values, that's why I mentioned RT. So class labels can be mentioned as fpt dot read dot, because we have all these names on different lines, we need to make sure that we are able to store all of them in a single array. So first of all, we will split them with the help of these line gaps that they have. For that we'll use rstrip, splitting them with respect to line gaps. Rstrip slash n is the line gap, and then split with respect to the same line gap. Slash n. This way we would get a list of all the objects. Now all the objects mentioned over here would be present in a list separated by a comma. Now I need to make sure that whatever image I have over here is loaded in my code so that it could be used. So I'll use a variable image, and image equals image file uh, image equals image dot open. Image is the module that we have imported from pillow library that would help us in handling the images. It basically helps us in loading the image in the code, and it also helps us in displaying it. So open image file, now whatever image we have obtained can actually be converted into a numpy array so that we can operate on individual pixels. This is something that you also learn in your college under digital image processing, where they teach you about matplotlib. They also teach you about computer vision, and a lot of operations are done which help us in modifying images and videos. So we'll just convert this to a numpy array that would be showing individual pixels. np array np array for image. Okay, so now images basically are created using RGB colors, but some of the images also include RGBA format. RGB for the color and A is for the transparency. So we need to check uh, what kind of image do we have. Is it a purely RGB based image, or is it following RGBA format? So if image dot shape and the second index in image dot shape, if that is equal to 4, then it means that it follows RGBA format. So issue with RGBA is that CV2 will never accept RGBA format. It accepts RGB format. So if we accidentally got RGBA format, then we need to make sure that we are able to convert it to RGB, which could be done with CV2. CV2 has a lot of options available for image processing. You can uh, change the image, you can transform it, you can shrink it, you can increase its size, then you can flip it. A lot of operations could be done with the help of CV2. So we would just use it to convert RGBA to RGB. If the image is following RGBA format, it would be switched to RGB format. So image equals CV2 dot CVT color, then image will be mentioned, then CV2 dot color transformation, color from RGBA to BGR or RGB. to RGB. So this will give us the image in the desired format. Now we'll get the dimensions of this pre-processed image. So we would be needing height and width. Actually, whenever we get the dimensions of an image, we get three different dimensions, out of which only two are needed. So we'll mention height, we'll mention width, and we will leave a blank for the third dimension. Then we mention image dot shape. So we'll obtain height, we'll obtain width. Then the third dimension is nothing but color channel, so we'll ignore the color channel, not needed for now. Now what we have to do is uh, we need to obtain a blob. Blob is nothing but an image that passes through the model that we have imported. So we'll create that blob. Blob can be created using CV2. We have imported the model. The imported model would be used. So cv2.tnn.blob from image. Image has to be mentioned. So I'll just mention the image over here. Input image img. So one can say that blob is the format that neural networks understand. They cannot understand direct images, so we convert it into a more understandable format, which is blob. So image, and then what we do is uh, we have pixel values. So whatever pixel values we have, we make sure that we normalize them. So let's say we have a lot of different pixel values which are having different ranges, like 230, then 130, then 20, then 100. So we make sure that all of them are converted to smaller and closer values. So 130, 230, 250, all of them would be converted to values that range between -1 to 1, to make sure that all of them are very close to each other and model can be trained easily. So that could be done by mentioning that could be done by mentioning 1.0 slash 127.5 0.5, and then whatever image we have, we can surely resize it. Resizing it can be done. So I'll just mention 320, 320 pixels height, 320 pixels width. Resizing is important because sometimes you might get a very large image, so you need to make sure whatever image you have fits in your screen. Then I would also mention these values, a tuple that contains 127.5 thrice, 127, 127, 127. So it helps in stabilizing neural network predictions, and I guess that's it, because we have converted it into RGB. Now we'll mention that whatever image we have should not be cropped. We should be able to have the entire image, so crop should be mentioned as true. Now this block that we created should be sent to the neural network. We have the neural network created with us. We'll just send the blob to that neural network. Set input blob. Okay, now we are pretty close to our completion. Blob is sent. Now we just need to obtain the detections. So I'll mention detections. For that, the image should be processed in the entire neural network So image would be sent in the neural network. The neural network will give me the prediction. Net dot forward. Now whatever detected results we got, we'll just process them. So we'll iterate over all the detections, and we need to make sure that we are able to show them on the image. So for I in range detections dot shape, we need the element present at index 2, because that is what we get as detection. So dot shape 2, then we need to fetch individual things. We need to know what the confidence is. If confidence is less than 50%, then our threshold is violated. Threshold clearly states that 50% is the bare minimum. So we need to know what the confidence is first. So confidence equals detections, and confidence is marked by the third dimension in the complete shape. So 0 comma 0 comma I comma 2. So this would be the confidence. Now we'll mention that if confidence is greater than confidence threshold, configurated threshold, then we can mention that we are free to show this object as a detected object. So I'll show the class ID. Class ID would again be obtained from the detections. So detections is nothing but a 4-dimensional array. In the 4-dimensional array, I am taking a ith value from the third dimension and first value in the fourth one. So it's similar to accessing values in a 2-dimensional array, just it's something that we are doing on a broader scale. So in a 4th-dimension array, this could be treated as a 2-dimensional array where we are selecting ith row and first column. So this will give us the class ID, index of the object. Okay, so person is having index 0, bicycle is having index 1, car is having index 2. Class ID will not give us the index, but it will rather give us the ID. Person is having ID 1, bicycle is having ID 2, car is having ID 3, 4. So this ID can be converted into index easily. We'll just subtract 1 from it. So the label can be obtained with the help of this class labels list that we created earlier, this one. So I'll mention it class labels, and in the class labels I would pass class ID, but class ID is not defining indexes. We'll have to subtract 1 with it for that. That's it. We got class ID, we got label. It would show us name of the object. We'll also show confidence with which the object was detected for transparency. And now we'll make sure that whatever object we detect, we are showing a box around it. So we'll draw that box. So box is equal to detections. In detections, again from the 2D array, from the 4D array in the 2th dimension, we'll get all the values from ith row. The values that we take belong to column 3 to 7. Okay, so this is nothing but these will tell us a few coordinates that would help us in plotting the box. We will obtain 4 different coordinates, one at the top left, one at the top right, one at the bottom left, one at the bottom right. All of this will help us in uh, creating a box around the detected object. So that's what we'll do. Detected coordinates, we obtain detected coordinates. Now I'll mention np dot array. Now uh, this top left needs a edge that is equivalent to width. This needs a edge that is equivalent to height. This bottom needs a edge that is equivalent to width. This needs a edge that is equivalent to height. So that's what we'll do. We'll multiply them with width, the top left with width, top right with height, bottom right with width, and bottom left with height again. This will help with drawing the box around that image. So we'll obtain coordinates from the box that we created. So we can mention that over here x1, y1, x2, y2 can be obtained from the created box, and we would be having these coordinates in decimals. So let's plan on converting them into integers for easier calculations. So we'll convert them into integers. Box.astype integers. So these are the coordinates. Now we have configured how the box would look. We have obtained the coordinates, but what we have to do next is we have to make sure that we draw the box, right? So we'll draw it on the screen using cv2.rectangle. We got the coordinates anyways, so now it would be easy. cv2.rectangle, rectangle is drawn around the image and is drawn with the help of the obtained coordinates x1 y1, x2 y2. Then color of the edges would be green, so 0 255, color code of green 0, and thickness of every edge can be 2 pixels. So this will help us with drawing the entire rectangle. Now we'll also make sure that after drawing the entire rectangle, we are also including the label above that rectangle. So that could be done by mentioning cv2.putText, and in the text we'll include nothing but the label and the confidence rate. So fstring label, with the label we are also mentioning confidence. So confidence, we need to make sure that it's only shown up to first 2 decimals. So for that we'll type 0.2f. So this will make sure that we are able to put text around the rectangle. Now this is just the text. We need to define the position as well. So position can be defined as x1 starting coordinate, comma, so x1 is denoting the top left, so x1 can be used, but we should mention that the position of the text is slightly above this coordinate, so y1 minus 10. Then we just need to select what kind of font we have. cv2 dot font Hershey complex, any font would work. Then we should mention transparency of that font 0.6, color of that font 0255, 0 green color, and we would mention thickness too. So this will make sure that font is added, the label is added with the confidence rate, and that's it. Now all we need to do is we need to show the final output. So we made sure that all of this could be done. Now we'll show the final output outside the loop. So final output is cv2.imshow detected object, detected objects could be multiple, and we'll include image. This won't be an ordinary image now, this would be a modified image which we have processed through the model and which we have modified with the help of cv2 to display detected objects with their confidence rate. Okay, just to make sure that after we are done using the project, when we close it, all the keys are shut, and all the windows that opened because of this project are also closed. So cv2.destroy all windows, and that's it, our project is done. Now let's try running it. Also make sure that whenever you run a project that includes a few libraries like this one, you run it in a virtual environment. Running it in virtual environment, make sure that it stays isolated from all the other projects that are there in your laptop. So let's run it now. Python object detection.py, object detection.py, enter. Okay, so we'll just try running the code now. Python object detection.py is what we use. Press enter. Okay, as you can see, we get the image, and this image is showing different people, and it's showing the green border that we spoke about. The green border is showing nothing but the label and the confidence rate with which the person was detected. This person was detected with a confidence rate of 0.68, the other one was detected with a confidence rate of 0.8, third one was detected with a confidence rate of 0.87, bicycle 0.65. So this is how we are able to detect multiple objects. So the model is working. If your code worked, great. If it did not, no problem. I have included the code with all the files needed to run it in the description in the repository that I have added. So just clone the repository, try running it again, it would work. So this is everything that we need to know about an object detection model that is capable of detecting objects in an image. Now OpenCV has a lot of operations related to images. We can flip the image, we can
rotate it, we can transfer it, we can shrink it, we can extend it, we can increase its size, make it brighter, make it dimmer. All the operations is something that we can learn easily, but this is one of the important applications of OpenCV, that with the help of machine learning and deep learning models, it can do wonders. Okay, you would have seen people doing similar projects on LinkedIn. So now, thanks to the series that I'm bringing, you would be able to do it on your own with a proper explanation. So we would be doing similar projects. If you did like this one, make sure that you mention it in the comment. If you do think that there is something that has to be changed, or if there is anything that I should teach, then please mention it. This is just the first video. If you did like the video, leave a like. Do subscribe if you are new to this channel, which you are. So subscribe to our channel. I will see you in our next video. Thanks for watching.